Hi, I'm George Magklaras, and this is a video to demonstrate Docker on RHEL 7. I'm here logged into the Red Hat customer portal. The Resource Management and Linux Containers Guide is a very useful piece of documentation, and I can actually use this excellent manual from Red Hat to explain some concepts here before I start demonstrating things. Docker is essentially a way to run Linux containers. What you have essentially is the Linux kernel and a number of technologies like that of namespaces, C groups, and SE Linux, and of course a management interface that helps you make the Linux containers and actually run something useful in them. Now, namespaces is a technology that allows you to isolate in a way and abstract certain resources. For example, there is a namespace for the process IDs. So each container has its own /proc file system. And in a way, while the host operating system can actually see the processes of the container can only see its own processes. But you also have, for example, ways to do the same for the file system. So you have, for example, the mount namespaces where you can actually mount certain parts of the host file system, and these appear to be unique in its container. You have IPSIM namespaces for inter-process communication, and also network namespaces that provide isolation of the network controllers. In other words, bits that help you forward traffic to and from an individual container using, of course, the drivers and the hardware of the host system. Docker, as I mentioned, is not the only way to run Linux containers. You could actually run Linux containers by using host containers and the virtual. That's right, the same tool that you actually use to administer virtual machines. So in this case, you have a very strong dependency between the host operating system and the runtime stack of the container. In other words, each application that you run in a container here has a one-to-one dependency with the runtime environment of the RHEL 7 host here. And that's good and bad. If you know that the applications are actually can actually run and they're 100% compatible with the environment of RHEL 7, then you have no problem. And in fact, the advantage of this approach is to that if you want to instantly update with one command, let's say 5,000 containers that theoretically, or 6,000 containers that you could run theoretically on a container host, all you have to do is to actually issue a yum update on the container host operating system. And this should actually update instantly all containers. However, if the applications that you want to run have very specific runtime requirements, you can actually separate the runtime dependencies for each application and make them a little bit independent of the container host operating system, and that's when you use image-based containers. Image-based containers is what I'm going to demonstrate in this video using the Docker technology. Essentially what you have is a platform image. So if you're a developer, for example, what you could an easy analogy you could think about is that of a source code repository, whether it's Git or SVN or CVS. So what you do is you pull or check out, depending on which version control system you use, a platform image. This platform image, of course, contains the basics of the runtime environment. On top of that platform image, you have a number of layers that are read-only, and these layers actually add certain bits and components that are necessary for your applications to run all the way in the container writable layer. If you want to make further changes and add more runtime dependencies, you can of course add them on the writable layer and then commit them back to the Docker repository so that other people can use the image with your own dependencies. And this is why one of the reasons why Docker is so useful. In essence, it's a very nice way to package your applications in a very, very hassle-free and efficient, computationally efficient way. Okay, enough with the theory. Let's have a look at the practice. So I'm sitting here on a Red Hat 7 system, and one of the first things we need to do, of course, after having our system registered in the Red Hat network, is to actually install Docker. And you can do that by actually issuing simply a yum-y install Docker. If everything works okay, you should actually get the relevant packages, one package from the yum repository. And at that point, you should actually have all that you need package-wise in order to start using Docker. Of course, Docker at the moment has just been installed. It's not active, so if you issue a systemctl status Docker, we see that nothing's running there. So I'm going to make sure that I enable it, and I'm going to make sure that I start it and verify that it has started. And yes, we see now that under the system slice there is a Docker service that's actually running. That's good. One of the first things you can do is to try and pull an image, and actually you'll need to actually search for a particular image. Docker contains a public repository. So let's say that for example, that I'm looking to pull or obtain a Fedora image. So I'm going to do a Docker search Fedora. That might take a while, and as you can see here, this command will actually try to search the public Docker repository, and will actually give me all the relevant images, available images that I can actually obtain and use locally in my Docker environment. Each image has a name, a description, which is basically what it does, a number of stars as it's actually voted by the users of the repository, and essentially you should also opt for trusted images, which means images that have actually been verified by the user community in terms of validity. In this particular case, let's say that I'm interested to run a container on Fedora that will actually serve an Apache web server. So I can actually do a Docker pull the image name Fedora/Apache. If I do that, you will notice that the system will start pulling the platform image and all the dependent read-only layers. So it might take a while here depending on your network connection. But anyway, in this stage, for example, we are actually pulling only 116 megs. So it's much more efficient than actually trying to FTP or SFTP a multi-gigabyte virtual machine image, which is the case in most virtualized environments. And eventually, after pulling all the necessary layers, you should actually get back to the command line prompt. Okay, that has actually finished. So now we can verify that we have an available image to work with by typing docker images. And as we can see, we've just pulled about 450.6 megabytes of data on the Fedora Apache, the latest image, which was created 9 weeks ago. Another useful command that you can do is that of docker info at this stage. And this is what you would normally do to see the number of containers that you want, the number of available images or image layers, where your data file is, where your metadata files are, and all the other information, useful information that you might need to know about your Docker environment. So now we have obtained the image. What we can do is try and make something out of that image, and that is by making a container with Docker run. So we can issue Docker run. You can actually, if you are unsure, consult the manual page. So Docker run, essentially the image name that you want to use, the command that you want to execute, and some other parameters like, for example, the name of your container, and etc here. Okay, so let's try then to run the container. So we're going to type docker run. I'm going to pass the -i -t t for tango arguments. I'm going to give it the name called first container, and then I'm going to base it on an image name called Fedora Apache, the image we just pulled on the previous step, and let's pass it the cell. If I do that, then immediately I get into a shell prompt, and surprise surprise, this shell prompt is not, we are not in the container host anymore, we are inside the container. If we want to see what happens in the host, we can, I have another SSH session here on the host, so we can type docker ps-a, for example, and indeed we see that we have a container, a unique container ID, the image with the tag, so it's fedora/apache latest, the command that we are actually running, which is an interactive shell at the moment, when it was created, what's the status, what ports it abides to, and the name of the container. Another useful thing we can do to inspect the state of the container is the docker inspect. Normally it's enough to pass the container name. So if we do docker inspect firstcon, which is our container name, and then pipe that to more, then we get all sorts of useful info about the state and the various attributes of the running container, like the host name, which is assigned by default by the Docker. It's a unique host name. Various aspects of the environment, the command that we are running, the image name, and then if we go further down, of interest, there are also some networking settings here. The process ID of the container running, that's 30,359. Going back to the networking information, obviously we use bridging here. There is the Docker 0 bridge, and that's its gateway, and through that gateway interface the IP address of the container, which is this one, 172.17.0.4, is actually able to communicate with the outside world. Host name path and host path, notice that these are actually paths that map to the host, the container host. So var lib docker containers and var lib docker containers, container identifier, hosts and host name are absolute paths in the host. So the host, the container host can see it, but these are all mounted in an isolated way via the namespaces code. So if you do an ifconfig, you can also see the Docker 0 bridge, which comes up automatically every time you start the Docker service. Okay, so let's exit from the container. We could actually remove the container by actually saying and stop it at the same time by actually doing docker space rm space container name. If we do that and then try to verify with docker ps, we see that the container doesn't run anymore. So that was a very basic demonstration of how one can create a container, pull an image, create a container, inspect the container, and stop the container. Okay, but so far the container just ran there. It didn't make anything useful. So what I'm going to do now is I'm going to demonstrate how you can run a real workload with a container, and how you can make that container available to the internet. And for that we're going to actually go back to the old command here. So we're gonna do something like this: docker run -i -t, the name of the container, the image, and the shell. But instead of stopping there, we also need to redirect the local port 80 of the container where the web server is going to run to port 8080 on my container host. So this is what the -p 8080 80 does here. And if we go ahead and execute that, we should be able to actually get back to the container. I am actually in the container namespace, so I'm gonna make sure that I go under the normal web server HTML file directory. There should be something like index.html there. And just to distinguish our Apache web server running inside the container, I'm going to say this Apache runs inside our Docker container. I'm going to exit and then attempt to actually start the in a rudimentary way the Apache web server. So let's see if the web server is running. Yes, it is. And the effect of this command is that if I now know the IP address of my Apache, the IP address of my container host, which is this particular one in an internal local area network here, 192.168.832, then I can map the Apache of the container running at port 8080, which I did. And if I click refresh now, then we see the Apache message, and we know that we have a web server inside a container running in our container host file.